We've all seen the incredible footage of the Iron Dome intercepting rockets in midair, but what you don't see is the hidden battle happening on the ground. Intercepting a rocket is only half the story. The other half, simply keeping the lights on. This is the LM-2084 radar, the eyes of the Iron Dome. To scan the skies, it emits incredibly powerful energy waves. Just to stay active, this single piece of equipment needs a continuous, massive supply of electricity, roughly the same amount as hundreds of homes combined. And this isn't a part-time job. It needs that power 24 hours a day, 7 days a week, because you never know when a threat will appear. Now, imagine the system detects multiple incoming rockets as it tracks these targets, calculating their trajectories and preparing to launch. The power consumption spikes dramatically. Then comes the launch. As multiple Tamir interceptors fire almost simultaneously, there's another, even larger surge of power demand. The local power grid has to handle these sudden, immense loads without even a flicker. A single moment of instability could be catastrophic. But what if there is no grid? Iron Dome batteries are mobile and often deployed in remote off-grid locations. This creates a huge logistical challenge. You have to bring in and constantly maintain large, dedicated generators and a massive supply of fuel. These generators become a critical vulnerability. If they fail, or if the fuel runs out, the entire multi-billion-dollar defensive shield simply goes dark. There's another hidden power hog: cooling. As the powerful radar and high-speed processors work over time, they generate an incredible amount of heat. To prevent them from literally melting down, massive cooling systems, huge fans, and liquid cooling loops have to run constantly. And you guessed it, these cooling systems consume a tremendous amount of electricity, all on their own. Without this constant, power-hungry cooling, the sensitive electronics would overheat and fail in minutes. Looking to the future, the challenge gets even bigger with systems like the Iron Beam. This laser weapon promises to be cheaper per shot, but there's a catch. To fire a high-energy laser, you need to charge up an incredible amount of electrical energy and release it in an instant. This presents an entirely new level of power supply and energy storage challenges for engineers to solve. So, the next time you see the Iron Dome in action, remember the unseen heroes. The continuous high demand of the radar, the massive peak loads during an intercept, the logistical nightmare of mobile power, and the constant need for cooling. The true genius of the Iron Dome isn't just in its missiles, but in the incredibly robust and resilient power engineering that makes the whole system possible. Thanks for watching, and if you learned something new, be sure to like and subscribe for more deep dives.